the podcast where we explore the latest research and advancements in the field of language models. In today's episode, we will be discussing a fascinating research paper titled The Science of Large Language Models, Investigating Causal Inference Skills. Causal inference is a fundamental aspect of human intelligence, and researchers have been exploring its application in natural language processing, NLP, through the field of causal NLP. However, existing datasets in this field primarily rely on empirical knowledge such as common sense knowledge to discover causality. This paper aims to address this gap by proposing a benchmark dataset called Core-2-Cause, which focuses on testing the pure causal inference skills of large language models, LLMs. The researchers curated a large-scale dataset of over 400,000 samples for the Core-2-Cause task. They formulated the task as determining the causal relationship between variables based on a set of correlational statements. To construct the dataset, the researchers generated directed graphical causal models, DGCMs, with 2 to 6 variables. They then programmatically generated d-separation sets based on these causal graphs and composed correlation statements and causal hypotheses for each sample. The validity of the causal inference was determined by checking if the proposed causal relation held true for all causal graphs corresponding to the set of correlations. 17 existing LLMs, including BERT-based models, GPT-based models, and other state-of-the-art models, were evaluated on the Core-2-Cause dataset. The performance of these models was measured using metrics such as F1 score, precision, recall, and accuracy. The researchers also conducted a fine-grained analysis to examine the performance of the best-performing model, Roberta Large MNLI, for different types of causal relations. The findings of this study revealed a key shortcoming of LLMs in terms of their causal inference skills. The models achieved performance levels close to random on the Core-2-Cause task, indicating their limited ability to infer causation from correlation. However, the researchers also discovered that fine-tuning the LLMs for this specific skill somewhat mitigated this shortcoming. Nevertheless, the models still struggled to generalize beyond in-distribution settings. They could only perform causal inference when the variable names and textual expressions used in the queries were similar to those in the training set. Out-of-distribution settings generated by perturbing these queries posed a challenge for the models. These findings highlight the need for further research to improve LLM's pure reasoning skills and generalizability in causal inference tasks. The Core-2-Cause dataset serves as a valuable benchmark for guiding future research in this area. By providing a standardized evaluation framework, researchers can develop new techniques and approaches to enhance LLM's ability to infer causation from correlation. While this study sheds light on the limitations of current LLMs in causal inference, it also opens up exciting opportunities for future advancements. By addressing the identified shortcomings, researchers can pave the way for more sophisticated language models that possess robust causal inference skills. This, in turn, could have significant implications across various domains, including decision-making, problem-solving, and understanding complex systems. To learn more about this research paper and access the dataset and code, you can visit the links provided in the episode description. Stay tuned for more episodes of The Science of Large Language Models, where we explore the cutting-edge research shaping the future of language understanding and generation.